Now we've got to a point in our exploration, through our world of matrices, where it'd be useful now to kind of consolidate what we've done by doing an exam question. And this is actually the June 2013, it's question 6 of the June 2013 FP1 Edexcel paper. And it's quite nice because it kind of consolidates everything we've done up to this point, as I say. So we're given this matrix X, okay, 1A, 3, 2. Told A is just a constant, just a number. And we're told to find the value of A, which makes this matrix singular. Now, if you remember that a matrix is singular if the determinant of it, so the determinant, this is the matrix X in this case, so the determinant of this matrix X is equal to 0. Okay, if it's equal to 0, then it's singular. So in other words, there's no inverse. Okay, so basically if we find the determinant of this matrix, and then if we set it equal to 0, then we find out which value of A makes this matrix singular. So how do we find the determinant of a 2 by 2 matrix? Well, if you remember, we treat it in terms of diagonals. Okay, so it's the elements on this diagonal multiplied together minus the elements on this diagonal multiplied together. Okay, so we've got determinant of X is equal to 1 multiplied by 2, which is 2, minus 3 multiplied by A, so that's 3A. Okay, and that's all got to be equal to 0 in order to be singular. Okay, so that implies it's just a case of now solving this thing. 2 minus 3A equals 0. So that implies that 3A equals 2. Okay, hopefully you can see what I've done there. And that implies then that A equals 2/3. So when A equals 2/3, then this matrix here is singular. Okay. Then in the second part of the question, we're given this matrix now Y, which is this matrix effectively X, but instead of A equals 2/3, because that would be singular, it's equal to -1. So immediately you know that it's non-singular, because the only value which makes this matrix singular is 2/3, and because this value here is now -1, we know it's non-singular. Okay, and we're told to find Y inverse. We know it's non-singular, the matrix inverse matrix must exist, so we're told to find it. So here we are. Here's the matrix written out, so we're told to find the inverse of it. Now if you remember, the inverse of a 2 by 2 matrix is given by 1 over the det of this matrix. So the determinant of this matrix. And then we alter this matrix, we fiddle around with this matrix. And how we fiddle with it, we flip the elements on the leading diagonal, and we negate the elements on the other diagonal. So we flip, flip, negate, flip, negate. Okay, so flip these elements, 2 and 1 swap places. And we negate these elements here, so -3 and 1. Okay, what's the determinant of Y? Well, it's going to be equal to 1 times 2, which of course is 2, minus 3 multiplied by -1, which is -3. So that's going to be equal to 5. Okay, so the inverse now is equal to 1/5, because the determinant now is 5, multiplied by this matrix here, 2, 1, -3, and 1. Now we could multiply 1/5 over all these elements here, distribute this 1/5 over all these elements, but if you leave it like that, that should be absolutely fine. Okay, now if we look at part C, we're told the transformation represented by Y, so Y is the transformation matrix, maps the point A onto the point B. And we're told that B has these coordinates, 1 minus lambda and 7 lambda minus 2, just told that lambda is some number. And we're asked to find, in terms of lambda, so our answer is going to have a lambda in it, the coordinates of point A. Now we haven't yet done transformation matrices, but that's okay. I think, the point here is, if I just tell you that, what the idea surrounding transformation matrices, the emphasis isn't in the transformation, it's on the idea that we've dealt with inverses. Okay, so we're told that the point A maps onto the point B under some transformation matrix. In this case, it's Y. Okay, B has these coordinates, so we know B, and we know the transformation matrix, because that was given in the last question, and we're asked to find what A is. Now, what we're effectively doing when we map A onto B is we're multiplying A. We can represent A as a coordinate matrix. Okay, and we know that we perform some transformation. In this case, the transformation is Y, and we end up at the point B. Okay. Now we'll come on to why we stick the y out the transformation matrix out the front later on, but it's just kind of we just do for the moment. I haven't yet done a video on transformation matrices. So basically we want to solve this for A. We know what B is, we know what Y is, we want to find what A is. Well, as you can see, the Y matrix is on the left. We really want it on the right. We just want A equals on its own, and then we can just read off the matrix which we get on the right. But at the moment we've got Y on its own. So what we're going to have to do is multiply by the inverse. Because we can take use of the fact that Y inverse times Y is just the identity matrix. It's the equivalent of just 1, and anything multiplied by 1 is just itself. Okay. So if we multiply by Y inverse on both sides, remember when we multiply by Y inverse, we always stick it out the front. Okay, whatever we multiply by, the new thing we multiply by, we always stick it out the front. Okay, if we didn't, then it's not the same, right? So this thing is going to be equal to I. So IA, which of course is just A, the identity matrix times A, which is just A, is going to be equal to Y inverse times B. Well, we know what Y inverse is. We've just worked it out. It's up here. Okay, so we've got 1/5 of 2, 1 minus 3, 1. Let me just check that's right. Yep, 2, 1 minus 3, 1. And we want to multiply that by B. Well, we know what B is. It's this thing here. And we're going to write it in, the coordinates going down. And we have to write the coordinates going down because it's going to be a 2 by 2 matrix. And then that's got to multiply by whatever this dimension is down here. The number of rows has got to be 2 because it's a 2 columns here. It's a 2 by 2 matrix multiplied by whatever this number here. It's got to be a 2 in order for us to multiply the matrices. Okay, it's going to be a 2 by 1. So the coordinates, let's put it in. So it's going to be 1 minus lambda. Then we're going to have 7 lambda minus 2. Okay, so it's just a case now multiplying this thing out. So we got, I'm actually going to distribute the 1/5 out. Don't have to. I could just multiply this matrix out. So I'm going to actually, or am I? No, I'll tell you what, I'll leave it there. A bit of indecision, I'm sorry there. So we're going to have 2 multiplied by 1 minus lambda, so we're going to end up with 2 minus 2 lambda plus 1 times this thing, plus 7 lambda minus 2. Okay, and that's all going to go in that column there. And then we're going to have minus 3 times 1 minus lambda, so we're going to have minus 3 plus 3 lambda, plus, then it's still going to be 7 lambda minus 2. That's all going to go in that element there. Okay, and then again, just a bit of fiddling around. The reason why I left the 1/5 out in the end, because we're still going to have this scalar here, so there's no point sort of complicating things. We could put all this over 5, but it just looks messier in my mind. So let's do a little bit of simplification. So we've got a 2 here and it's minus 2 here. Those are going to cancel out. And we're going to be left with minus 2 lambda plus 7 lambda. So that's going to be 5 lambda altogether. Okay. Then here we've got minus 3 minus 2. That's going to be minus 5. And here we're going to have 10 lambda. So we're going to have 10 lambda minus 5. And now what I'm going to do is multiply this 1/5 out. Okay, because this 1/5, there's a factor of 5 in both these terms. So we're going to end up with lambda on the top. Maybe I'll show you what I'm doing as well, rather than just doing it. So we've still got 5 lambda, and we're just going to put this over 5, multiply by the 5th. And then this is going to be 10 lambda minus 5, all over 5 again. Okay, well 5 divided by 5 is fairly obviously just 1, so we're just going to have 1 lambda here. Then we've got 10 lambda and minus 5 here. So how many, when we divide by 5 of both terms? So we're going to end up with 2 lambda minus 1. And there we are. There is our matrix, which we're after, our A, our coordinate matrix. So in other words, 1, you don't have to write this in the exam. These coordinates map to the B coordinates of 1 minus lambda, 7 lambda minus 2 by the transformation matrix Y.